Page 3 says at the top, I paid over $100 for my calculator. Why is it so important to know what the shape of the graph will be? Well, here's the equation for a parabola. I got y1, so I'm going to put it in the calculator. X minus 10 squared minus 55. Let's take a look. I've got that in there, x minus 10 squared minus 55. And if I do the usual thing of just hitting zoom 6, I see this picture. And someone who has no knowledge might assume, well, this graph is a straight line. Sure, it looks like a straight line, a little jagged, but it's still a straight line. But we should expect from this form of equation that it would be a parabola with its vertex at 10 for x, negative 55 for y. This doesn't even go, well, you can't see that far over really, and you sure can't see down to negative 55. If we change the window, instead of just going from negative 10 to 10, let's go all the way over to 20. And instead of only going down to negative 10 on the y-axis, let's go to negative 100. And now I'll hit the graph key and we'll see what that looks like. Now we're seeing the shape that we expect. And if I hit trace and punch in the 10, you see there it's verifying that the turnaround point, the vertex, is at 10, negative 55. Okay, so that's just another little side note about why we do all this work. We can understand things better. Now, when we talk about a minimum or a maximum in the context of quadratics and parabolas, we're talking about the highest value the equation can have or the lowest value. Highest value would be a maximum, lowest value would be a minimum. And when it's what is the minimum or maximum, tells us the largest, and put parentheses, or smallest output value. The y. Where, that tells us what x value to use to get that largest or smallest output value. Where tells us the x value used to obtain the max or min. Okay, so here's a guinea pig right here. We'll use this 2x minus 3 squared minus 6. And I'm going to draw it over here. And I'm going to show you another little trick for drawing the graph without using the calculator. The vertex, it says take away 3. So the x value of the vertex is at 3. And there's a minus 6 on the outside. So the y value of the vertex is at minus 6. There's 2, 4, 6. So there's the vertex. Okay. And then watch what I'm doing here. Since that a value is a 2, if I start here, I go over 1 and up 2, and then over 1 again and up 6, and then over 1 and up 10. 2, 4, 6, 8, 10. And I can do the mirror image on the other side. See, over 1 up 2, over 1 up 6. Okay, well, there's the graph. And let me explain now how I knew how many boxes to jump up. When it's just y equals x squared, you start at the vertex. At first you go over 1 and up 1. If you look back at all the graphs we did of x squared, you would go over 1 and up 1, and then you go over 1 and up 3, and then you go over 1 and up 5, and then over 1 and up 7. Do you see a pattern emerging here? It's just the list of the odd numbers, 1, 3, 5, 7, etc. If there's a multiplier here, like a 2, multiply everything by 2. Go up 2, go up 6, go up 10, go up 14. If there was a 3, we'd go up 3, 9, 15. Get it? Simple. As long as there's a convenient vertex, not a vertex that's at some decimal value or fraction value, it's an easy enough pattern to use. And it's faster than even punching everything into the calculator and using the table function. Okay, anyhow, let's see if we can answer all these questions. Does it open upward or downward? Well, it opens upward. You saw that over there in the picture. We know it opens upward because the a value is a positive 2. That's the reason. What is the vertex? Remember, it's x minus the x value, and then plus the y value on the outside, and we could say that's plus negative 6. So the vertex is at 3, negative 6. What is the minimum or maximum y value? Well, with the graph opening upward, there is no maximum. It goes up forever, but there is a minimum. There is a y value that's lower than any other possible y value. And what is it? It's negative 6. Where is the minimum or maximum y value? It's at x equals 3. So let me point out right here that these two questions get answered by looking at the vertex. What the minimum is the y value. Where that minimum occurs is the x value of the vertex. What about domain and range? Domain for any of these parabolas is always all real numbers, negative to positive infinity. And the range, look at the picture and let it help you think. It goes down only this far, it goes up forever. The range is from that x value of negative 6 up to infinity. Negative 6 to infinity. And something we haven't mentioned yet, axis of symmetry, that's the imaginary line that's like a mirror right in the middle of the thing. We draw in typically as a dotted line like that. And what would the equation of that vertical line be? The equation of a vertical line is x equals whatever number x is stuck at. That's going to be, the vertex is so useful. That's the x value of the vertex. The equation of that line is x equals 3. Okay, so let's write that in here. And we'll try this one now. The a is negative 1, and h, if we rewrite this a little more stringently, I could say this is negative 1 times x minus a negative 2 squared and plus 5. So the a value is negative. That means it's going to open downward. The vertex, it's take away negative 2. So it's negative 2 for the x value and positive 5 for the y value. What is the minimum or maximum y value? Well, let's draw the graph first and then we'll answer that. It'll be a little more meaningful. I'll start at the vertex. The vertex was at negative 2, 5, which is right here. Did I count that right? 3, 4, no, I'm sorry, right here. Mr. Dane can't count. Erase that. Okay. Now, remember the over 1 up 1, over 1 up 3, 1, 3, 5, 7 trick back there? So this is a negative 1. So instead of going up, we'll go down. Over 1, down 1, over 1, down 3, over 1, down 5, and then down 2, 4, 6, 7. I'll do it one more time. 2, 4, 6, 8, 9. Did I count that right? 2, 4, 6. Yeah, okay. And same thing on the other side. Down 1, and then down 3, and then down 5. And we get this much of a picture of an opening downward parabola with the vertex at -2, 5. And now looking at this, we can say there is no minimum for this. It goes down forever. We can get as low as we, excuse me, as low as we want with the y value. There is, however, a y value higher than every other, which we would call the maximum y value of the function, or the maximum value of the function, and it's 5. Excuse me. And where do we get that? At x equals -2. The x value of the vertex. And the domain, still all real numbers. And the range, it goes down forever, starts, you could say, at -infinity and never gets any higher than 5 exactly. So the range is -infinity up to and including 5. And how about the axis of symmetry? That's going to be the vertical line. X equals -2. Goes right through the vertex. So it's x equals -2. One more thing on this page. We're not going to bother to draw the graph. Will this have a minimum or a maximum? Well, it's got a -a value, so it's going to open downward, and that means it's going to have a y value higher than every other, which we call a maximum. It will have a maximum of, what will that maximum be? Well, the vertex, I said I wasn't going to draw the graph, but this is just a little thinking sketch. Let's take away 23, so the x value of the vertex is 23 plus 37. The y value is 37. It'll have a maximum of 37. The highest y value will be 37. The highest output will be 37 at x equals 23. That takes care of page 3. Thank you very much.